Okay, we're at 17.6, electrical energy and power. Let's go to the PowerPoint. Okay, you can see that the battery, the power supplies that we've been using in the lab, they're little electrical units. But if you have a battery, a couple of C cell or D cell batteries, or basically what you're doing is you're turning chemical energy into kinetic energy of the electrons moving through the wire, and the kinetic energy is quickly lost into the as it goes through the matrix of the conductor or the resistor. So you're going from chemical energy to kinetic energy to thermal energy. You're transferring the uh, it's an energy transfer system. The the positive current travels clockwise from the positive to the negative terminal of the battery. So the current, the conventional current, I, shown here, is going from left to right. The actual electron flow is out of the negative and going around in the other direction. But we use conventional current, which is positive. So the limit of uh, the charge divided by the time times V is equal to I delta V, and that's power. That's the power is equal to the current times the current times the voltage. Now, there's a little mnemonic. Let's see. Well, they have it here, but I'm going to show you. I'm going to switch over to the iPad. Let's do a new share with the iPad, and it should be coming up shortly. There it goes. So here's a little Ohm's law mnemonic. The delta V IR, you make it kind of like a little pie chart. I mean, some of them I've seen where they just draw a straight line across like that. I kind of like this one. This is the one I learned when I was at tech school at SAC way back when, back in the mid 70s. The And you can see that if you're looking for delta V, well, that's equal to IR. They're right next to each other. If you're looking at for I, well, that's V over R. That's this one here. The first one I said was here. And if you're looking for R, well, that's delta V over I. It's a little mnemonic. Well, if oops, wrong one. If P is equal to I delta V, we can say, well, we can substitute delta V. We can see P is equal to I, and instead of the delta V, we can say IR. So that's equal to P is equal to I squared R. And we can also do another substitution. We can go back here, P equals I delta V, and we can see that I is equal to delta V over R. So delta V over R for I times delta V. Oh, well, look, that's delta V squared over R. Okay, so that should help you remember how that little mnemonic will help you remember these little power formulas. So let's go back to the PowerPoint, and you can see that we have P is equal to I squared R, and it's also equal to delta V squared R, all from the Ohm's law. So, all right. And the example here, the 1 kilowatt hour is a kilowatt is 10 to the 3 watts times 3,600 seconds. And that's 33.6 times 10 to the 6 joules. So there's an example of some power expressed as kilowatt hours. Okay, next is superconductors, and I think I said at the beginning that we're going to skip superconductors and we're going to go on to the heart. So we'll stop that here.